So at Stitch Fix, something that people may or may not realize is the breadth of data science that we do in the data products that we support. So at Stitch Fix, there's an algorithm for just about anything from styling algorithms, algorithms that match our clients to our stylists, algorithms that assist in various forms of human computation, algorithms that control batch picking in the warehouse, pick path optimization through our warehouses, what warehouses clients are styled from by our stylists, then merge algorithms that handle inventory replenishment, allocation of that inventory across size breaks, classes, and again, warehouses. We have a team that's dedicated to doing demand modeling against the service. We even have a team internally we call Frankenstyles, which I guess I'm not supposed to say, but I just did. I forget the official term for this, but that helps us create brand new styles that we roll out under our private labels. So just about anything at Stitch Fix or any aspect of the business at this point has an algorithm or data product that is integrated to make it better and more personalized. And so we as a data platform support that wide breadth of R&D and data products and production. So as I mentioned, we've got a few people on the line today for Q&A. We have Bruce Wong, who is our Director of Data Platform, Derek Bennett, who manages our data infrastructure group, so the group in charge of Presto, Spark, Kafka, Druid, all of our data storage and related infrastructure. Laura John, who is our Director of Data Engineering. Thomas Millar manages our algorithms enablement team, which is the group responsible for all the APIs that serve out our data products in production to other engineering systems, and then me as well. And so once we get through content here, quite a few people to aim questions at, and hopefully a broad array of perspectives that we can offer. So some context on our tech stack. We're 100% AWS shop. We run a lot of Docker containers on Kubernetes, do a lot of data processing in Spark, Kafka for messaging and event bus, Presto for ad hoc queries and dashboards and lightweight R&D. And then the majority of our data scientists are writing Python and R code. On the platform side, we also have a good healthy bit of Scala and Java, as well as some core platform services, and our experimentation infrastructure is all written in Go. So some basic tenets of what we develop for at Stitch Fix. One of the primary things is we try to create autonomy across all groups, and what autonomy means for us is no handoffs, right? So we don't have teams that are oriented by specialization. We have teams that are oriented vertically into the business, or at least our data science teams are. And we do that so that they can own their research and the delivery of that all the way from conception to production. We feel like that avoids a thinker-doer split, which leads to frustration and lack of productivity. So we do our best to avoid the thinker-doer problem. And that means R&D, prototyping, and production happen with the same people involved the full way across. On top of that, we provide autonomy to iterate. And so we want that to apply equally to our data science teams as well of our platform teams, and that means providing good service boundaries, good knowledge of who owns what, and allowing that ownership to happen with full autonomy to control that space. The caveat to that is doing something for the first time may require coordination, right? So if we have to create a brand new integration into our engineering systems, or acquire a new form of data, or integrate with something that we haven't seen before, that requires cooperation and cross-functional coordination. But the goal is to make that a one-time thing in order for iteration to happen on top of it autonomously and in a loosely coupled way. So right, integrity of the interfaces and visibility is the key to achieving that. Another thing to note about Stitch Fix is we're not a big data shop, which is actually, given the size of the department, something that we can exploit quite a bit. So we only have about a petabyte of data. We can debate it, but I would assert that's not a whole lot. And we seek to exploit that when building infrastructure. So Peter mentioned a couple of us on the line actually come from Netflix. Netflix likes to joke about being a logging company that also streams movies. The implication of that is there's a ton of data over there, which is true. At Stitch Fix, comparatively, there is not. And what that means is that we don't need to focus on innovating to deploy the largest EMR cluster or Kafka clusters on AWS. We can innovate on the tooling and support to our data scientists to iterate on top of our stack and be autonomous and maximize their productivity. So it really allows us to focus in a spot that isn't scaling to our data size, which is great, and then leverage the work of much bigger fish to do that for us. So when we talk about scale, if we're not scaling to data size, what is the scaling factor for Stitch Fix? And it is the breadth of data products that we support, and just the size of our data science department, which is over 100 data scientists. So we relative to even the number of data scientists in the department, and certainly our data volume and size, the breadth of data products that we support at Stitch Fix is much greater than most people often expect when they come in or hear about the department. So just a few facts to ground things and kind of give y'all an idea of the scale that we're running at. We run about tens of thousands of batch jobs a day on our infrastructure, which is a scheduler based on Airflow, and then like we mentioned, a bunch of Spark and containerized jobs that are running. So that includes model training, featureization, analysis of our A/B tests, all of our reporting and analytics and dashboard creation, as well as ad hoc research and, well, frankly, anything else you can imagine that seems reasonable to run on there is probably running. On the online side, we peak at about 2,500 inferences per second. And that's across the board of recommendations, simple tests on the online side of the business, warehouse algorithms running across the stack, all of our data products. Our production jobs run mostly Spark SQL and PySpark on the batch side. That runs on top of a system that we call Flotilla. So on the big data kind of distributed computation side, Spark and PySpark, a lot of our ML work happens in single containers where we can just push a bunch of memory at it, again, exploiting our small data sort of context. And and that's happening data science code deployed in either Python or R. And so our pipelines, when we talk about tens of thousands of jobs a day, we have fewer pipelines than that. So a pipeline to train a model or do various other things consists of several jobs that span the stack of the tech. So there's typically some Spark ETL that's breaking things into various data sets by maybe inventory class or whatever the case may be. And then feeding into these containerized Python or R jobs to do some computation, and then probably back up to a Spark pipeline to consolidate things and shuffle data around. Those pipelines that we're talking about, again, back to the point of autonomy, are owned end to end and iterated on by our data scientists. So there is no handoff from, for example, our data engineering team to the data science team as far as like requirements or specs or shared code. The iteration is happening autonomously on both ends. And I'm sure Laura would love to talk about that or field questions at some point. We used to brag about not having a data engineering team, so that's certainly something that we've changed our mind on along the way, and we get a ton of value there. But we have our special flavor of autonomy built on top. So to give you an idea of what infrastructure looked like, just a few slides that might motivate some questions. We do data acquisition into our environment through state snapshots that happen every night of our various engineering databases that run our transactional systems, as well as constant data acquisition through logging and instrumentation on top of Kafka. All of that goes into S3-based data warehouse, and the metadata on top is mapped into the Hive Metastore, which makes data available to Spark and Presto, as well as all of our Python and R clients through an interface called Magic Carpet. On the Kafka side, we acquire data from a ton of different sources. So our engineering systems push a lot of data onto RabbitMQ. There's a lot of stuff on top of SQS. We're consuming all of our syslogs and web logs, as well as external events instrumented inside of JavaScript and internal tools and external, as well as change data capture from various databases floating around. All of that is pushed onto Kafka, synced into S3, and then optionally other sources as well. So a lot of stuff goes into Elasticsearch. A lot of stuff goes back onto Rabbit or SQS to power other applications, and then a lot of it goes into our online feature store to serve out models in production as well. Derek and team have done a ton of work in building abstractions and interface on top of that, which we playfully call the DMV, and tooling on top of that called Caltrans. And so that's basically tooling that allows us to manage that Kafka pipe and related ecosystem that we call the data highway at Stitch Fix. And it gives a fair amount of abstraction to our data scientists, so they don't need to know the details of operating Kafka, but can achieve the benefits of integrating on top of it. Inside of our Sparkiverse, we have kind of an interesting infrastructure. So we're running Spark on top of a variety of EMR clusters. And in the slide here, we're calling that production and development, but there's actually a few clusters that we operate. The way that jobs get deployed onto the clusters is through an interface that is developed in-house called Zeus. So Zeus is basically a REST interface that allows job submission onto our EMR clusters. Um, those those jobs are then allocated to one of the running clusters as appropriate, right? So like we have a few production clusters, we've got dev cluster, we have internal sort of R&D clusters or staging clusters that the team uses to test out a variety of things. Data scientists don't know which one is which necessarily, so we can respin our clusters behind the curtain, and what the Zeus interface does is provide a degree of abstraction so that data scientists don't have to worry about that, and we don't have to coordinate with them when that's happening. So our driver containers spin up on top of a system called Flotilla, which is the same system that's running the single container ML jobs that I was talking about earlier, which are Python and R based. We also use that to launch our driver containers that execute onto these clusters. That's all happening on top of Kubernetes. And from a batch perspective, that gets submitted through a system called Futura, which is basically an abstraction that we've built in-house on top of Airflow. A lot of the work that we do involves not necessarily machine-to-machine interaction, but machine-to-human interaction. And so that includes a variety of business metrics, reporting, analysis, self-service through Looker, as well as a variety of richer, sort of more interactive read-write type data products that we expose into the business. So for example, dashboards that will provide recommendations to our buyers and planners as to what inventory to purchase and how to allocate it across classes, or tooling that can help design the Frankenstyle type in-house styles and clothing that we are developing. And so that kind of stuff couldn't be powered through Looker. It needs to be sort of these custom applications. And so we try to make that as easy as possible. And this is a illustration of the stack that's deployed on. A lot of React apps going through there. We also use a fair bit of observable, and that gets all exposed through a layer that we call Daylight that handles authentication and permissions and logging and all of the stuff that you don't really want data scientists worrying about or reinventing the wheels on at kind of the edge of delivery. And then flipping over to the online side, machine-to-machine integrations into our various transactional systems and our client experience happens through a system called Mixer, which is what is our service mesh that production models get deployed on. It handles a variety of things. It handles routing to the right algorithms based on awareness of A/B testing and things like business line. It also handles resilience, so it deals with our fallback strategies. It bakes in distributed tracing for free, and it is capable of shadowing traffic across environments. So for example, if you're doing local development or have deployed a new model into staging and you'd like to shadow production traffic on top of it, that's a button press away with Mixer, and really helps to flesh out our development story for our data scientists. And we've got Thomas Millar on the line, who is the designer of that whole ecosystem, and I'm sure is happy to take questions there. And with that, happy to take questions from the group, and just a reminder of who's on the call. We've got Bruce, who in a former life over at Netflix is the one of the masterminds behind Chaos Monkey and Chaos Engineering, and is really focused right now on platform and fleshing out our resilience and reliability story on the online side of our data products. Derek Bennett, who manages all of the big data infrastructure, so Kafka, Spark, Presto, as well as Druid and others that we've talked about on the call, and then Laura John, director of our data engineering team. Basically our ETL patterns, the way that we handle data, and our core data model is what she's focused on, as well as instrumentation of all of our online systems onto our event bus. And then Thomas Millar, the online serving side, and then I'm happy to take all kinds of questions as well. So
great, thanks, Jeff. Yeah, so folks can feel free to unmute themselves or punch in questions in the chat, and the Stitch Fix team will be happy to answer them. I just wanted to ask one thing, not to go back in time too far, but I know that folks will want to ask lots of detailed questions about your current systems, your current architecture, et cetera. And it's awesome that we have so many great technical people on the line. I just wanted to ask from sort of more of a startup's perspective, because we have folks in our community who have all sizes and shapes of data teams, or maybe even not data teams. They might be a single data engineer, data scientist at a startup trying to figure out how to build a practice. I'm just wondering, before Stitch Fix got to be a 100+ person data team, what lessons do you have from the very earliest stages of data nascency at small companies? How would you encourage them to think about building their team or structuring their team? And what tips or tricks or gotchas can you mention that you think would be helpful to folks who are just starting off on the journey of trying to build a really resilient data practice over time?
Yeah, that's a great question. And I guess for some context, at least a couple of us on the line. So Thomas has been at Stitch Fix a little bit longer than me, but we both joined around 6 years ago when the team was nowhere near the size it is now. So I think it was between 5 and 10 people back then. And the platform team was almost non-existent. So it was, I think, 3 of us. And certainly none of that existed. None of what we've talked about on the deck existed at that point. And the challenge was, putting ourselves in a position to get to the place where we are today. And so, I think one thing that maybe we had an advantage of over at Stitch Fix is, we kind of knew by the nature of the business that it wasn't going to be, a huge data shop, right? So like we had interesting data and a sufficient amount of it to do good data science, but we didn't have sort of this massive scaling problem up front that we needed to design for, and we knew that wasn't something that was going to rapidly ramp up in the future. And we also knew that there was sort of an intention and buy-in from all the executives at Stitch Fix that a huge competitive differentiator for the company was going to be our data science, right? So like we knew that the team was going to scale, and so making bets for the future with that respect wasn't risky at all, right? Like it was just a matter of time and creating a runway for it. And so with that in mind, we were making some like long-term bets, but you've got to start somewhere with only 3 people. And so I came into it with a belief that if you can control the way data is read and written, you can actually create sort of an abstraction layer between data scientists or people operating on the data warehouse and sort of the infrastructure that you want to future proof. And so that's where we really concentrated first, is getting that like Hive metadata layer in place, and establishing sort of the way that we wanted to physicalize the data in the warehouse, and not making that optional, right? So like that was the only way that you could communicate to the data, is through platform supported readers and writers, and then that handled the physicalization and metadata mapping. And I think that was a good guardrail to allow us to kind of scale into a lot of the batch infrastructure side without having to redo a lot of stuff. And so that was a good learning. I think something that we were late to is getting a really healthy messaging infrastructure in place. And so now we have something that I think is awesome with Data Highway, but that was something that I wish we had done a little earlier. So that's, I guess, from relative timing, is like 4 years old versus the 6. So it's been around for a while now, but was harder to spin up than it should have been, just given the timing there. And then I don't know, I don't want to put Thomas on the spot, but do you maybe have a couple insights around the online serving side, seeing as how you've watched it evolve over time?
Yeah, from the model serving side, it was really about, well, I mean, honestly, we didn't do model serving through like real-time APIs for a very long time. And so I think that was probably like the right call, is figure out the use case and design the infrastructure around it. So in a lot of ways we were kind of late to the game with like deploying APIs and services, because our API wasn't necessarily a REST interface. It would be, hey, we're going to provide a data dump over into a database or something like that. So I think the key things that allowed us to get up to speed there on the model inference was like really analyzing the use case and designing the infrastructure around it. Eventually, you're going to need APIs and whatnot, but like we didn't dive into that before we needed to. That was kind of like a big theme in the arc. And so also for context there, it was probably about 4 years ago when we actually started getting into like APIs. The first 2 years was mostly just data dumps, and that was kind of how we exposed models out to the business, which is, I think, relatively kind of uncommon.
I think one of the things I would add on that question around like how to think about the investments you make early that help you later is, I've never regretted putting an interface in place to kind of separate concerns. And I think that's both true from an engineering and data science perspective of like what that looks like. So getting a good contract between two different orgs or teams or people that's unified, respected, and agreed upon. Those are the things that allow you to scale behind the scenes, because you have a predictable pattern and a predictable interface. Now, those interfaces you build early on, I think there's an art to like, don't build it too early, but don't build it too late. I think Thomas had a good saying of like, do it the hard way once, do it the hard way twice, then look at like building an interface. And I think the time, like you'll find that the investment you make in interfaces earlier will pay off long term, because then that allows two different teams to kind of separate the concerns for whatever we're building. And I see that in a lot of the investments that Jeff and Thomas put in very early, that a lot of those interfaces are still the same interfaces today that we have. They're just at a dramatically larger scale, and we've been able to involve the systems behind the scenes thanks to that.
A little bit in the history there, kind of piggybacking on what I was saying earlier, is the latency of inference is not so much an issue if you like batch compute the inferences, which is something that we were able to leverage at the scale when, for example, when I first joined, we would run a nightly job that would compute all the inferences and load it into a Postgres database. Then the latencies, it's just a lookup. So the big thing that we've like dealing with latency and model inferences is always an issue. It's not like a solved problem. It depends on the use case. The general techniques that we've used, like we kind of have a framework by which we solve latency issues, and it generally boils down into like do less work is the main thing. So often you'll see you kind of user, to get really concrete for a second, there's, the first kind of model that we worked on that we were using inferences takes a client and takes a style and predicts the probability that they're going to buy it. And so you take your entire client's table and you do it for every single style. You're doing tons and tons of inference, even though in reality, in our product, you only ever observe like less than 1% of those numbers. And so there's like key observations of saying, okay, we'll do less work. We're doing, 100x more work than we need to. And so design the system around that and be able to get that confidence signal to allow you to only have to do the inferences on the data that you need. That obviously is a lot easier when you have kind of APIs. It's a little bit different for batch compute. So there's a do less work, make things parallel. I have like a list written down somewhere. There's like do less work, make things parallel, and then only at the last point do you start considering using better technology. So it has come up where we said, oh well, if we just program this in C or something like that, or Julia or something, it would be so much faster. And you say like, okay, that's a last resort, because what you're optimizing for is the rate at which you can develop models. And because that's the thing that's going to push the business forward, not making an existing model faster. So you try to use engineering tricks to make the models faster instead of like rewriting the model from ground up. I don't know if that kind of answered the question. I don't know if it.
I'd also add one thing to that is like we've had some wins around like representing the data in a smaller footprint. And so there's optimizations you can make around, like if it can fit on disk, that's one optimization instead of going all the way to S3. If it can fit in memory, that's another optimization. And every time that you're able to represent the same data in a smaller footprint, you get latency benefits because there's less network, there's less disk and IO. Like the smaller footprint of that memory, like gets you pretty good step changes in latency performance. So that's kind of along the same lines of do less work that Thomas talked about. But I think there's also another vector of like, are we representing the data in a way that, is there something there for us?
I think something that we've learned along the way as well is just maximizing sort of ROI. And so like a key insight into that is the expected lifetime of an interface that we're building is several years versus the expected lifetime of a model is maybe 3 months in production before it gets rewritten or beaten by something else. And so, if we spend our time optimizing the interface, that's great ROI because it's got staying power. Whereas if we spend our time optimizing the implementation of any individual model, that might have a massive benefit for 3 months, but then it's going to evaporate when the next greatest thing comes along.
One thing that kind of Bruce reminded me of that I wanted to highlight is that like data representation. An example of an optimization that we put in was these APIs. Generally, they're feeding data over JSON, but we have kind of an internal optimization where we know if the data being returned by a model can be represented as a data frame, and we'll use like PyArrow under the hood. But the really key thing there is that optimization is kind of interesting technically, but the key kind of lesson learned is not that optimization. It's that we didn't put that into the model code. we put that into the platform so that and it's to kind of Jeff's point, is that because any individual model only exists for 3 months and we have hundreds of models deployed into production at a given time, any optimization that we tackle, we tackle at the infrastructure level as to the best of our ability. And that's really how we get leverage.
So I wanted to ask Laura a question, since Jeff, you hinted at the fact that culturally at Stitch Fix, perhaps there's been more of a focus on enabling data scientists to do awesome stuff. And maybe even sometimes that's been at the expense, at least in label, of the data engineering team. But Laura's obviously, you've had to build an engineering team. So I was wondering if you had any sort of feedback or comments on the challenges and opportunities of what it was like to build a data engineering team at Stitch Fix.
Yeah, I came in, it was clear there was a lot of overlap and a lot of duplication, and people didn't feel like there was a central model. And then, given a lack of ownership, people also wouldn't feel comfortable making changes to that. And so they made their own things. And so, everybody cares about our data around our clients and the shipments that we send out. And it turns out we had like 4 or 5 different versions of client data that didn't have the same definition, that sometimes didn't match. Like we had applied different business logic against it, and no one knew what was correct. So there's definitely opportunity for centralization there. And it turns out there's like quite a bit of data that ends up being a great fit for a central model. And so our team kind of like decides what that is, like what should be central, what is going to be used by enough people that it makes sense, that we're not going to, block anyone from, we also just kind of like, if somebody needs something and they need it now, like then you could make the thing now. We're not going to kind of stand in your way, but we do look for opportunities. And I think that's an interesting, that's been a really cool experience at Stitch Fix, is that I get to just look for opportunities of like things that I see people doing that should be more central. And so, so our team has built out some frameworks for kind of like consolidating business logic and letting that be a central thing, instead of like people having 50 ETLs that have like different metrics that they're calculating. We've built a framework that has like a single place for you to find a metric. You mentioned who's created this, who owns it, how is it, like how do we derive that, and people can call from that to kind of use that themselves. So we try to look for a lot of opportunities to centralize things, which has been a pretty exciting opportunity.
And is that like a data catalog? Is that, do you use that term, or is that the general concept of what you're describing?
Yeah, we call it the metrics and dimension foundry. So it's like a Python YAML-based system that builds Spark SQL for you. And so a little bit more than a catalog, I would say.
Yeah, I can take that. Jeff, do you mind going back to the mixer slide? I'll just help give a little visual. Yeah, there we go. So for coordinating model versions in production, currently where we're at with our infrastructure is that all models kind of get packaged up and get deployed in a Docker container and are surfaced through a kind of a JSON API, REST style API. And as we mentioned earlier, we have Mixer, which is kind of our routing layer. So in our deployment tool, it's highly optimized to like be able to create a new application very quickly, because as we said, we're developing new models. They only last 3 months. We're going to be spinning up a lot of services, a lot of distinct kind of model services. So, you can really think that kind of on every deploy, we're kind of creating a new application, unless we're doing like hot fixes and bugs. And so as a result, you'll see many services. You'll have kind of a different service deployed with a different URL for each kind of model version number. So you'll have like match scores v12, match scores v12.2, and whatever. Each of those is deployed as kind of like the implementations of interfaces. So we have a few interfaces, and then we have tons of services which are mismatched implementations for these interfaces. Then what Mixer does is when a request comes in, it comes in for a request will come in for the logical, like, hey, I want match scores. I don't really care what version. As the engineering application, they don't really need to know. They just want to show the recommendation in an app. What Mixer does then there, it says, okay, it has a registry of all the different versions. So model V11, V12, V13. It'll have targeting rules as well to say, okay, this implementation can only service women's clients because it's an optimized model just for this subset of the population. So it kind of goes through kind of a simple kind of logic, and then it will determine which are the candidate models that it can actually communicate with. Then it will go out and talk to our A/B testing service and says, hey, is there an active experiment running on the logical match scores model? If so, tell me which specific version to control. And that's through our Fab experimentation platform, fully self-service. A data scientist can just go in there and say, kind of drag and drop, here's my model. It's, an implementation of match scores. I want to create a test cell, 20%, whatever. And then Mixer automatically integrates with that and routes the appropriate request. Now, on the shadowing front, every single request into Mixer, due to Derek's kind of great infrastructure with the data highway, every single request for a model will generate a log with the inputs to that model and what decision or which specific model it got routed to. That gets logged out to Kafka, and we go and we'll throw that into our data warehouse in S3. And in the shadowing mode, we provide a couple of tools. So we have this local traffic shadower, which allows you to kind of like tail off that topic and filter it down to the specific request that you care about and route it to something on localhost. And then this is for kind of a live development experience. But then also in production, what we'll do is you can create those kind of tail requests, set them up in production. It has, it will route, every request to V11 will also get duplicated through the messaging pipeline and hit V12. And then what happens is we'll automatically create, so we use Lightstep as our vendor for distributed tracing. We'll create Lightstep streams so you can go and analyze performance and error rate for those kind of, core operational metrics. But those models can also log out the results and once again, go through the messaging infrastructure into the data warehouse for you to do kind of deeper analysis to say like, hey, match score V12, has a different distribution of responses than V11. And that's something that you can do. And it's completely safe because it's just those requests are captured and replayed. It doesn't affect production performance at all. It's off the log stream. And it goes all into the data warehouse for analysis. So we can do some pretty advanced stuff of deploying new models, make it very easy to deploy new models, have them shadow any existing model, and capture the results and throw them in the data warehouse for kind of deeper analysis to figure out like, hey, if I rolled this out, like what would the effect try to do those counterfactuals, like what would the effect on the business would have it been had I actually rolled out V12? It's a little kind of complicated in the analysis. We don't actually provide the tool to actually do the analysis for you. We leave that to the data scientist because it's specific to the model and the use case. But yeah, hope that answers the question.
I'll take a stab first, and I think we all have, like, what I'll say is we all have different challenges and problems. And I think that's what makes part of this fun is that there's no shortage of challenges and problems. But one of the big areas of focus for us in the near term future is we're really looking at how do we think about I'll call it interactive interactive personalization or interactive recommendations. And what I mean by that is, what is the client experience that we can build as you like walk through or shop with us, as you navigate an interactive experience. How do we utilize our recommendations there in a more real-time fashion? And so, I'm glad that we had a question about latency, because I think that's very top of mind for us. Because I think about what's the 200 millisecond recommendation that we can make? What's the 2-second recommendation we can make? And then what is the 30-second recommendation that we can make? And I think we're in an exploratory phase that we're getting into of like, how do we balance and scale that latency and scale the exploration of like that tension between latency and accuracy, and then how do we provide that in an interactive way with our end clients. And so as they navigate through our recommendations, we're getting more data as they're interacting with it. And so then how do we use that and update in real time? Because every time I look at a shirt, every time I zoom in, every time that I'm like, oh, like this seems interesting, or I save it off to an outfit that I might want. Like all of those interactions are an opportunity for us to work with. Now, I think in a traditional like e-commerce world, there's a notion that we'll save those off and it will update recommendations tomorrow. But we're really looking and branching into like, well, why should we wait till tomorrow? You're at the site right now. So can we process something and return back to the experience within milliseconds, and to evolve that experience in a way that gives you more and more to interact with, and that gives you more like the experience of Stitch Fix should become more and more personalized as you interact with us. And so we're really moving we're removing that time horizon from like days and weeks of calculation down to seconds and milliseconds, and finding that feedback loop as fast as we possibly can. And I think that's a new horizon and a new like domain that we don't know how that's going to look today, but we know that there's a pretty huge opportunity for us to like build infrastructure, build interfaces, and build experiences. Now that's the high level. And I think there's a whole bunch of challenges for each of our respective teams on how we have to think about the work of a data scientist and how it fits into that world, and how the infrastructure needs to do more to enable that future. So that's a high level. I think Derek, like we haven't heard from Derek yet, so maybe Derek can give some of his insights onto some of the challenges that he's facing in the future.
Yeah, there were a couple things I did want to add to that. So one of the things that we're working on, and of course this involves my team, but involves some other teams also, is we're trying to get to we're trying to make model training easier and kind of like make that process faster. And so one of the things that's involved in that, for example, is being able, like having a data scientist being able to prototype a model and the training of that model with a smaller data set on their laptop. And then once they're happy with that and they've done some detailed validation of that, then turn around and run that like in a cluster somewhere, which depending on what they're doing, that could be within Spark, or it could be something else, pulling data out of Magic Carpet and feeding a TensorFlow model or something like that. So I think being able to sort of track those and being able to sort of run them in different ways with data coming from different parts of the infrastructure is definitely something we need to expand on and make easier for data scientists. And it's not that so much that people can't do this today. It's just that we need to make the process faster, more traceable, and make it easy for data scientists to go back and sort of look at versions and do comparisons and things like that. So there's a lot of things that are involved there. Going along with that, we're seeing a lot of cases too where we've gotten like tons of mileage out of Spark for ETLs and analytics and things like that, and that's gone really well. But for machine learning models, there's kind of like mixed feelings and mixed results about doing all of that in Spark, and so we use a lot of different tools that sort of don't play well with Spark for one reason or another, and but we still need to get data for those. And we're looking at some other ideas on how to do that, where for example, they could run a giant ETL in Spark and then move the data to a cache somewhere that they could run through iteratively, like as they're doing iterations and doing hyperparameter tuning and reading the same data again and again. So just to give you an example of that, I mean, I was just looking at our Magic Carpet query logs just to see how many jobs we were running, for a given day. And there were a couple days, like the average is kind of in like the 30 or 50,000, individual queries, you could say, every day. there was one day where it spiked over 300,000. And I'm pretty sure that was like an iterative model run that was like reading the same data multiple times. And, the good news is we have a cache, which makes that possible. But, there may be some other options there. So I think like for, at least in my area, and again, it spans other teams as well, I think that's like a big thing that we have to look at, to make data scientists like be able to iterate through models quicker and sort of get good results quicker, because that's just becoming more and more important, and we're seeing examples of this happening already today.
I can add a bit on some of the challenges, problems on the data edge side. As Jeff mentioned, like a petabyte, we don't have big data, but it's definitely growing. And especially as we move more towards capturing what clients are doing on the website and offering more things on our website for clients to purchase, we have bigger data, I think, than we've had before. And so that growing quickly, and that data being something that it's not like a current state, it's more transactional, like, events that are constantly happening. So it's changing a bit the way that we process some of our data. I think we're moving more towards doing incremental more often. Historically, we didn't really need to all the time. Our data wasn't so big that we couldn't just process everything forever and save it. And so along with that is just making sure that we're thinking about how we store our data. So we've moved a lot more towards Parquet, and thinking about how we partition and file sizes as well. That's something we have to care about a lot more as we move towards bigger data. People start to notice when things are slower. And on the data edge side, we build a lot of these core and central things that work for the data scientists, but they also feed into Looker, which is like people coming in and getting kind of metrics, and they're expecting to get those in 5 to 10 seconds. And so when we introduce some new source that takes 2 to 3 minutes to query, that takes everybody else down with it. So we're starting to think more about kind of like how we serve that data, and just making sure the whole team is really thinking about that, but also still kind of enabling the autonomy that we have today. So it's a thing we're thinking about, like how to address over the next year and make sure that everyone knows the implications that it has.
Yeah, going back to the data highway for a minute too, just thought of another thing that kind of fits into this. So lots of work going on in that area as well. I mean, so we've just expanded the size of our Kafka cluster, for example, because we're seeing, we've definitely seen a growth in data. I mean, since we've rolled that out. And the good news, another thing I'm excited about is that our engineering team is also going to be moving towards Kafka as well. So we'll be essentially sharing data between our Kafka clusters, and we'll have multiple Kafka clusters across Stitch Fix instead of just one. I think that's going to open the door for a lot more things and make the integration between us and the engineering teams a lot easier, and open up the door for a lot more real-time data as well. We're also seeing like some payoff from using, kind of frameworks around that, such as Kafka Connect. So an example of where that's paying off is like the security team wants to get some of our logs and kind of capture those, like to, have something to fall back on in case there's, they need to trace back through API calls that have been made like across different systems. And so we're writing kind of our own connector to pull the data out of one of our Kafka topics and send it over to security, where they'll warehouse that and kind of query that when they want to. And they're also pulling in data from other data sources so they can correlate these different events. So I think I expect more of that we'll probably be connecting more data sources and a different variety of data sources. So again, it's kind of going along with some of the other themes of, there's breadth as well as volume that we have to think about.
So the team has talked a bunch about real-time data, both in serving predictions, in dashboards and reports. I'm curious, do you folks have a notion or a belief around so-called streaming data?
The streaming is kind of related to like the data highway kind of enables like streaming for us, and we have like a couple things going on there. So one, we have the system that his team has built on top of the data highway that it kind of involves a lot of streaming client features. And that's kind of interesting because it allows us to, what they've done is they've allowed us to pull additional data from engineering databases and augment like what's in the messages and make those data sets a lot richer. So that's kind of the nice thing about that. We've also got a kind of more general Spark streaming setup that's starting to get more usage, and we're seeing more use cases for that pop up. So we're doing things like running some, constantly updating aggregations on experiment data. We're looking at a new project now where we're going to be analyzing some clickstream data and kind of using that to power some more real-time recommendations. So we're definitely seeing a lot more of that over time. And again, moving from just doing fixes to doing fixes plus a lot of interactivity with the customers and shop is definitely going to lead to a lot more of those over time.
One way that I kind of think about streaming data, and Derek kind of mentioned this, is that there's like two kind of use cases. So the system that Derek referenced that the team built was I really frame it more as like an elaborate like pre-caching scheme for what we do in the data warehouse, where we have something that computes off the snapshots that runs every night. And then this messaging infrastructure allows us to update those values. And I really think about them as like, scalar values on a table. So there's no kind of aggregation to them. And we kind of really leverage that. It limits its use case, the use cases that it can serve, but we have kind of a need and a solution for that. And then there's the other dimension, which is really about those aggregations, which like historically we haven't, when the thing that I think why we steered away from it historically is because they're much harder to maintain. And because we're looking for like data science autonomy, you start to get into these Lambda architecture style things where you need to, write your logic in the streaming application and write it in the data warehouse for kind of batch analysis. And there's just kind of a higher burden of operation. And so when we were focused on kind of, hey, what's the ROI of these kind of investments? It's just for a long time just didn't seem to pay off. I think now as Derek mentioned, we're revisiting a lot of these things around like streaming aggregations because we're starting to see more use cases for it where it can pay off. But it's something that we've been reluctant to do in the past just because the operational burden of these kind of Lambda architectures is quite high and not very amenable to like individual data science autonomy.
I'll say a quick tidbit before I pass off to Jeff to close us on this one. I'd say your team structure is going to evolve similar to how your systems evolve. And so it depends on scale. Like Jeff mentioned that like we now have Laura and her team, and like it's a fantastic addition to the team. But when you're 5 to 10, like that is the team. And so I think a lot about the similarities between how systems scale and how organizations scale. And so my short answer is that it will evolve over time as your domains change. Jeff?
Yeah, I mean, that is a very good answer. I mean, I can tell a little bit about how we're structured specifically at Stitch Fix, and to Bruce's point, it's not the right shape for everyone, and it's not always been the right shape for us. So it's what we think is the right shape for us right now. But something that's unique to Stitch Fix is we have a chief algorithms officer, and so that means that our data science org is sort of a top level org in the company, which at most companies you would see it under engineering or I don't know, in other maybe more crazy places, like I've seen it under finance, I've seen it under operations. It's not at Stitch Fix, and so that means we have an engineering team and we have an algorithms team. And under that algorithms team, we've put our sort of horizontal infrastructure, so our data platform, and the folks on the call today. A lot of companies are going to deploy that sort of as shared infrastructure across all of the technology org at Stitch Fix. we see our data platform as kind of a support org to enable data science, and that's just sort of it's due to the fact that we see data science as a key differentiator to the company, and so we want to basically allow maximize focus of our infrastructure on enabling that algo development. And so from an infrastructure perspective, we've got the folks on the call. We see them as horizontal, and it's roughly split between online serving machine to machine, which is Thomas, machine to human, which is, we had a slide on it, but basically like all of the dashboarding and interactive kind of data visualization, data product stuff. And then our data infrastructure teams, which is Derek, right? So like kind of that core batch infrastructure and ETL scheduling and deployment, as well as all the R&D and streaming use cases. And then on the data science side, like those are mostly, again, vertical teams, right? So like those are full stack data scientists that are working on vertical business problems. So that's typically functional partnerships within the business. So like merchandising, we have a merchandising data science team. We have a big styling operations group, and personal styling and our stylists are a key aspect of our business. So we have a styling algorithms team at Stitch Fix. And then the client experience, again, is some combination of marketing technology, as well as now like the fairly rich interactive client experience that we're building out on the website. And so we have a client algorithms team that focuses on those sort of data products. And over time, we've seen more horizontal kind of work evolve from that. So, Laura's team building the core data model is an example of sort of like horizontalization of data needs, and then like horizontalization of like R&D and data products, or things like a team that focuses on global optimization of our merchandise across channels, for example. Or Thomas had talked about this probability of purchase. So given an item and a client, what's the probability that they're going to purchase that? That has applications that are pretty ubiquitous across our vertical stacks, right? And so we see those as now horizontal teams that are deployed in the org. And so anyway, that's kind of a snapshot of how we're organized today, and just maybe also like an insight into the evolution of that is as things become more ubiquitous, they become more horizontalized. But our default is like this sort of full stack deployment of data scientists integrated into a business function or sort of a business context that they're working through.
Well, thank you, Jeff, and thank you to all of you for joining us. It was great to have you here, and I really appreciate you sharing your insight and experience with the community. How can folks find you if they want to ask follow-up questions? I can just have them email me, and I can give the human router, or, oh, here we go, @stitchfix_algo on Twitter.
Yeah, feel free to tweet us, and then I don't know if anybody wants to screenshot. We've got all of our contact info up here, but we do actively monitor that Twitter account and love to engage there, as well as email, or feel free to utilize Pete's offer to route questions to us as well.
Great, excellent. All right, well, thanks again for joining us.
Awesome, well, thank you so much.